So good morning. I think we'll get started. So I want to thank everybody for sticking around. This is the third and final day of our full programming, and it's wonderful to have you here. I'm not going to belabor all the details of the agenda, but I do want to take a moment. I want to thank everybody who has attended and given presentations, all of the folks who helped us organize sessions. It's been really successful so far. I'm sure I'm not jinxing anything for today. And I especially want to thank members of our RemPlex team. It wasn't really obvious perhaps who all of us are, but everybody on our team really helped pull together the concepts and the ideas for the summit. And I'm really grateful to that, but I'm going to quickly just say Judy Robinson and Inchi Demer-Conley, they organized and chaired the Hanford session. Chris Johnson had his hands on lots of parts. I'll probably forget all of them, but he organized the PFAS panel and the Moab case study and the technical session on data management. Delphine Apriou collaborated with him on that technical session. Rob Mackley, who is walking in right now, the head of our Deep Vadosome program, and a lot of the work that's been presented by PNNL staff has its roots in that program. And David Peeler, who is deputy manager for our environmental management sector. He'll be up here a little bit. And then Nick Chafulku, I don't know where Nick is, but Nick's had his hands on everything, and he's really part of the inspiration and collaboration, and maybe even a little bit conspiratorial with me. So that's great. I want to thank Kelly McIntosh, who holds down the Office of Logistics, Practicality, and Sanity, at least my sanity. And then Melissa Purdue, I don't think she's in here, but she's the head of our communications team, responsible for all the graphics, the beautiful stuff you're seeing. I do want some of you to be sure to look at the scrolling marquee out in the lobby, because you show up there in living color. And helping Melissa, Jess Hernandez, who's here with us in the back, she's been masterful, and they've been supported by Liz Gurel, masterful at pulling together a lot of electronic content for us. And of course, Blake Wright, who has made the entire thing possible in this building for us. She's done all the arrangements for the catering, the buses that took people on the Hanford tour, all of the registration. So literally, this would not have happened without Blake, and her colleague Vanessa Witten is out helping with the registration. And then finally, I didn't know I was going to make a new best friend this week, but I did, and it's Mike Dawson, and he's in the back in the IT space. And I thank you so much, Mike. He's done a lot to juggle and get everything in the right place at the right time. So with that, I think we'll move on to the opening session. And we have two speakers this morning. You've met Tom earlier, and I'll just ask Tom to come up and do his thing. As a reminder, he is the manager of PNNL's environmental management sector, and he's also the director of RemPlex. Thank you, Tom.
Thanks, Karen. Appreciate it. So Karen asked me to talk about looking ahead to the future. And I terrorized her and Kelly McIntosh by thinking about this for many weeks and pulling thoughts together as the RemPlex Summit progressed and pulled some thoughts together for just finalize those last night in just in time. So real time presentation, Brian. So anyway, what I wanted to do was talk a little bit, reiterate a few things we talked about yesterday in terms of what a complex site is. Figured at the last day of a 3-day session on complex site remediation, I might reiterate a little bit about what a complex site is from our perspective. And then talk a little bit more about some things that I think probably came out most in the Moab session yesterday. Brian talked a bit about adaptive site management and what it means to him or doesn't mean to Brian. I wanted to touch on that a little bit. I have an example from Hanford that I like to show that we didn't talk a lot about, but it gets at the issue of a complex site, but not everything is complex. Not everything needs to be, studied and understood to be able to take action on a cleanup effort. So I wanted to highlight something that kind of enabled Hanford to really make some substantial progress over the last 20 years, despite the complexity of Hanford. And then I want to end with really just asking for help from all of you as we think about what we've done this week, what we're trying to do with the notion of RemPlex, and ask you to think about how can we, where do we go from here, and how can we help continue to bring this dialogue and collaboration and communication, forward. So that's really what I wanted to cover, and so I'll step back to some slides that kind of were used at the very formation of RemPlex. Don Wellman, who was here at PNNL at the time, had really kicked this idea off of formulating this kind of focus on this, and it really arose, in Don's view and our view, from the recognition, starting more than a decade, 20 years ago, actually, in terms of EPA's recognition of technical complexities and their impact on effectiveness of remediation at hundreds of thousands of sites in the US, billions of dollars, hundreds of billions of dollars worth of liability associated with those sites. And the fact that these technical complexities, not just technical, but certainly in this case, technical complexities were kind of impacting the ability to make progress on those sites. And Brian mentioned the National Research Council yesterday, the National Research Council report from 2013 and the ITRC, one of the ITRC communications from 2017 that really point to this problem of closure, accelerating closure and getting to closure with sites because of these complexities the easy approach to it isn't working. I think another key point I'll get to, Chuck Newell mentioned yesterday, the 70s and the 80s and kind of the approach we used, and when he was talking about PFAS and this overwhelming, what do we do now? The easy things that we've applied didn't always work, but we progressed and progressed. And I'll talk a little bit more about that. So what makes a site complex? We like to use this kind of cartoonish view of sort of representing Hanford as a complex site, but really the fact that there are multiple sources of contamination, multiple contaminants, commingled plumes that you see in some of the indications on this slide from different sources, a complex geology, for example, perch zones and the heterogeneities that compound our understanding of where the contaminants are going, how to get amendments in if that's what we're doing, how to even improve the removal of those contaminants. And another one I'm not sure we've talked a lot about, but I'd like to add here is the impact of all of the biogeochemical and physical processes in the subsurface that we don't fully understand that impact that contaminant fate and transport, and impact our remediation strategies and the complexity of that added on top of it. So these certainly aren't all of the things that make a complex site. Another one, which will be obvious from my little example from the Hanford case study, is a site of huge magnitude with thousands and thousands of sites, and how do you tackle a large industrial complex and the contamination associated with it when it's almost overwhelming in terms of its magnitude, which is where Hanford started in the late 1980s, trying to figure out how do you even begin when you've got thousands of sites. So another thing, Brian mentioned the adaptive site management, particularly the recommendation for Moab, and certainly kind of consistent with the strategy at Moab. I wanted to pull a few things up relative to that. So the first part of this is, the elements of adaptive site management that the ITRC documents in their publication and their website. These three elements of refining the conceptual site model, and really the point, Brian brought it out well yesterday, this iterative refinement over the project life cycle, that you learn as you go and you refine that site conceptual model and improve your understanding and be able to learn enough to take incremental actions on the problem. Another point they make is set and revisit the site objectives. And here they're talking about the overall site objective. What's the overall objective of the cleanup? Make sure that's very clear. And that's the overarching one. And then the last part, develop interim objectives so that you can initiate remediation, learn from it, and then adapt as you learn and go forward. And we have this bottom set of figures here is something we put together for RemPlex. It's kind of our RemPlex framework from our perspective that is relatively consistent with an overall in the US CERCLA or RECRA process for a site action, but it also kind of builds in some of the elements of the adaptive site management that we like to emphasize. And that is, we start with not just a conceptual site model, but we emphasize as much quantitative information as possible. And then your goal is to update that quantitative site conceptual model over and over iteratively as you gain more and more information. As you're gaining information from interim actions or the initial remediation stage, keep doing that. The thing that's not shown here is really the do loop arrow that is constantly feeding back and revisiting that. And anyway, that's just a point I wanted to make that is kind of key to certainly at PNNL, our philosophy as we work with our customers is focusing on that iterative process. And there's a few more elements on there that I think people will recognize and may have questions about. We can certainly talk about those. I just wanted to kind of reemphasize that because that's really a core thing on a complex site. Brian mentioned yesterday his dislike for the term adaptive management because it implies in his mind that maybe it's an excuse not to take action immediately or to learn more before you take action. And I completely agree with your comment that that's not what it is, and it's important that it's not a call for more study. It's a call to action and study in an integrated, iterative way, and that's what makes it so critical for these complex sites. So with that, that's why I wanted to go back in time a little bit and talk about a Hanford example that I've struggled with mentally, emotionally. I was here at the beginning of the Hanford site cleanup. I got here in 1987. The cleanup started in earnest in 1989, and we were in 1987, 88, 89, 90. That period of time, there was a large increase in work to develop characterization technology, remediation technology. We did some seminal work in bioremediation of chlorinated organics at that time, including a demonstration in the Hanford site in the early 90s on carbon-tet biodegradation. But what I struggled with at that time was this admiring of a problem. Thousands of very poorly characterized sites across Hanford, including both concentrated stored waste and dispersed contamination throughout. Future land use wasn't clear. There was a land use group that was formed and working, but it wasn't clear where we were headed. The challenges had not really been previously addressed at such a magnitude of scale. Thinking of this size of a site with this much contamination and lots of unknowns. And I don't think it was clearly articulated at the time, but ultimately it became these three components of the river corridor, the area adjacent to the river, all the way from right where we are today up around the horn of the following the river up and up to the B reactor, the central plateau, the broader central plateau where all the processing was done, and then ultimately the discussion of an inner area or inner core, which is where the majority of the disposed waste and process facilities, D&D, that needed to happen existed. And the strategy evolved fairly quickly, but it was a struggle, and it was I know when it first started, a study was started that they called macro engineering. And this was just a nice way of saying, suck, muck, and truck. That was the strategy was being developed. And at the time, I thought it was nuts because it was kind of like something Chuck said yesterday about, pump and treat. Already at that point in time, we recognized that pump and treat was getting, a lot of visibility of not being a permanent solution, not being effective, even in late 1980s, that great hydraulic control, but not a solution to the problem likely. And just bringing in bulldozers and digging stuff up and moving it somewhere else seemed like, why are we going to tackle this site in that way? And it took me a long time to come to grips with this, but I'll say, so this was the overall strategy that was developed in those, early 1990s. Remove, excavate the waste sites, especially along the river, particularly along the river, to protect the river and the structures there, and move that waste up to the central plateau. Groundwater treatment would be used, pump and treat would be used to contain, remove mass, but mainly to contain as a measure to contain and hydraulically control, and stabilizing the reactors for long-term isolation, which some of you may have seen if you went out on the tour on Monday, and then develop a very large disposal facility in the central plateau to receive all of the waste from the river corridor. So that was the overarching strategy to protect the river at the time. And I'm speaking mostly around dealing with the 100 area, the river corridor area. There was, in parallel, a lot of work going on in the concentrated waste in the plateau and what to do with those. But I struggled with this because we had lots of development going on new advanced characterization, new technology. The going thought was you've got all of these individual waste sites. We've got to characterize every one of them. We've got to go and develop a strategy around every single one of them. Maybe we can group some together, but this is a, we got to try to do the right thing for every, depending on what each site looks like. And this macro engineering approach was basically saying, we got a lot of stuff that looks all the same, and we need a cost-effective, efficient way to protect the river and most expeditiously and least cost. And the reality was that a site by site effort was not going to be cost effective, was not going to be efficient in time, and probably would not do as well to protect the river as taking an approach of remove the soils, you build an infrastructure to do that, and you just churn and get it done. You build a disposal facility that enables you to actually take action early and move stuff off the river and protect the river, and make significant progress. And you've got a place to put all the D&D debris from that remediation. So to me, it seemed like a brute force, not very elegant. And is that really what we want to do? But quickly you begin to realize as progress is made, that was probably the perfect action at the time to minimize the risk. And it's kind of akin to Moab, I think, in terms of getting the waste removed, get it somewhere else, protect that river, and it's not the end all for everything, but it allows you to make progress and get there. And so I just, it doesn't undermine the fact that this is a complex site and there's a lot of complexity left that we can really focus on in the notion of RemPlex. Because there's a lot of things that are going to take 40, 50, 60 years or more to deal with, but at least progress can be made to get us to a point where now we understand those problems better. We understand the chromium contamination deep along the river that isn't being very effectively covered by pump and treat because it's held up in the vadose zone. It's too deep to excavate. Now we can tackle those very limited number of complex challenges as opposed to 1,000 complex challenges that we think are complex and actually could be handled in a more effective way. So I just wanted to give that example because it was one thing that I lived through and kind of wondered about in terms of the role of technology and science, and certainly there was a lot of science and a lot of technology that was applied there. And just to give you a sense from some of the ways that the site looked, so these are pictures of 100D and 100H that I'm going to show, where here are the D and DR reactors. And, this is the, the reactors are cocooned, the large excavations were done. And then today, basically, well, not today, but almost 10 years ago, but that's pretty much, stabilized, cleaned up, major stuff removed. Similarly in 100H, and so as an example, then so then we start to think about, okay, so now what's with the complex sites that are left? What are some of the trends? What are we talking about this week in terms of things that are helpful in terms of complex site remediation? Clearly, adaptive site management is one of those, but I just listed a few things as examples of the types of things that we're talking about, and the things that we're focused on, and not all exhaustive, but advances in characterization, monitoring, integrated remedies, emerging contaminants. Clearly, PFAS and other things are going to be the next big challenges for us after we tackle some of the current ones. And then a plug for forest sustainability and resilience, which is a big part of now how do we think about this in a more long-term sustainable and resilient way. So that is essentially my comments, and I wanted to leave you with a little bit of where do we go from here. So we are going to get a survey out to everybody that attended, where we really encourage a response from all of you and thoughts from all of you in terms of the utility, the value of spending a few days with a group like this, relatively small, but able to focus on some challenges and really share lessons learned and collaborate. There's a couple of things we're doing in RemPlex. The Global Summit every couple of years, every 2 years, is one thing that we're committed to keep moving forward on. We do seminars throughout the year, try to do those in a collaborative way with partners to build and focus on some topics of interest that can help advance the notions of this. We're always looking for other ideas, other things that you think would be valuable as a way to keep this dialogue and the communication and collaboration going. So we welcome your feedback. We want you to be candid about what you think would be helpful for us. So if we had time today, I'd take 15 minutes and pulse you, but I'm gonna end there. And if we have a couple minutes, that's great. If anybody's got suggestions or comments or thoughts, I'd love to take them. But I don't want to eat into horse time either. So thank you.
So now I get to introduce our next speaker. It's Dr. Horst Fernandez from the International Atomic Energy Agency. And before I get into his particulars, I'll just say that I've had the pleasure to work with Horst now collaboratively for over 15 years. It's always rewarding, it's always rich. And I really appreciate that he stepped up and has started collaborating with us and organizing the summit. It's a big contribution, Horst, so thank you very much. And the particulars are, Horst is a environmental remediation specialist at the IAEA, and in that position, he oversees a large spectrum of projects that address different types of environmental remediation challenges for various nuclear scenarios and for naturally occurring radioactive materials management, NORM. And he is also the scientific secretary for Environet, which you ought to check out because I like to co-promote it as another way of networking and finding people to collaborate with on remediation. And Environet stands for the Network of Environmental Remediation and Norm Management. And Horst, I'm sure you're going to tell us more about your work, and thank you very much.
Thank you, Karen. So, good morning, everybody. It's really a pleasure to be here in RemPlex. Privilege to talk to you and emphasize that we get great support from PNNL in our activities, but from the USA as large as a great partner to deliver assistance to our member states. We started with Don Wellman, and then we went to Mike Truex. Now we have this collaboration with Karen, Chris Johnson, and Nika Fuku, and Tom Brown. So we are expanding our activities in that sense. And it's very important that we can count with these partners, because although Karen referred to me as environmental specialist, that's the title they give me in Vienna, but the specialists are you. And we work towards our member states needs through you and not through me. I'm just a scientific secretary that have the role to identify the resources and make these resources available. So we depend very much on the network that we have to address the needs of our member states. So, well, the slide's a little bit different. The thing is that IAEA, for many people, is a kind of acronym, but eventually there's no clear picture what IAEA is about. So I thought that could start by providing a little bit of flavor of what the organization is. So our mandate is essentially to accelerate, enlarge the contribution of atomic energy to peace, health, and prosperity throughout the world. Definitely, it was created on the Eisenhower program of Atoms for Peace, and the main mandate of the agency in the beginning was safeguards to control nuclear materials to avoid proliferation. And then we expanded our activities to include the use of atomic energy to the prosperity of the world. So we have 175 members affiliated to the agency. We only lose for the Federal International Football Association in terms of affiliation of member states. We have something like 2,500 staff from over 100 countries. So we are in a very multicultural environment, people from all over the country. And that's a very interesting opportunity, but a challenge at the same time, because we need to work with different mindsets. And sometimes it represents real exciting opportunities. We have laboratories in Cybersdorf, in Monaco, and in Vienna. And we have regional officers in Toronto and Tokyo, and also liaison offices in New York and Geneva, where the United Nations is the headquarters of the United Nations. We have activities in science and technology, safety and security, and safeguards and verification. We are in total something like 5 technical departments: nuclear safety, nuclear energy, nuclear science and application, safeguards, and technical operations. So this is the way we are organized. So we are cognizant that we have 420 power reactors, over 50 power reactors under constructions, most of them in Asia. And we have about 30 countries considering introducing nuclear power. And so we help them to see what kind of steps they need to take into consideration to have nuclear power. So we organize missions in that particular aspect. So more to the back end that we are talking about here, we help member states to manage radioactive waste, spent fuel. We have a lot of work in the decommissioning of nuclear facilities, and of course, remediation and contaminated land and legacy sites. How do we do this? We have publications with a lot of the very important aspect of things we do. Public technical publications. We have networks. We organize peer review missions. We have training workshop and courses. We have e-tools like e-learning. And also we organize expert missions under the request of the member state. So we organized a training course in August here. Amoret was with us, Karen as well. So it was something like, I don't know, 20 plus participants from 18 countries. And it was a very exciting experience, because it's very nice to have all these people working together and learning from the experience of a country like yours. So it was a very interesting opportunity. So these are some of the activities that we have in all over the world. Now, into my presentation that is about integrated sustainability and circularity concepts in determination of end state in the Commission and Environmental Remediation, I thought it would be nice to talk to you about a conference that we had recently. When I say recently, was last week, and I share with you some of the findings of this conference, because the conference was interesting. It was ensuring safety and enabling sustainability. The main thing here is that safety is a prerequisite for sustainability, but the highest degree of safety might not entail sustainable solutions. So we need to find a compromise between what is safe and what is sustainable, because this is really the key point. So the conference was essentially supposed to address these particular aspects. So it was aimed at discussing sustainability during the back-end management. We're focusing on the back-end of nuclear and radiation technologies, applications, and activities. And there was always questions about what is sustainable and what is the perception of the stakeholders, and activities to be performed having operational safety mindset. And as the conclusions of the conference, sustainability was seen to be somehow embodied in safety standards and radiation protection. So we have a bunch of publications that we call the safety standards. Safety standards are documents that are produced with the member states. US is part of that, essentially through the NRC in most of the cases, because the safety standards are produced mainly by regulators. And this is an issue. This is an issue that we need to think about, because we need to put together the perspectives of the operators, the industry, into the context as well. But mainly it's documents that are produced by regulatory bodies representatives. The point is that sustainability might be seen as implicit in these documents, and the conference called attention that we should make it more explicit and demonstrate how these things can be achieved. So this is an important thing. So making it more explicit, by no means indicating that sustainability has been systematically considered in decision-making in relation to radioactive waste management, decommission, and environmental remediation. Safety is an integral part of sustainability and therefore linked with the UN SDGs, the Sustainable Development Goals. But optimization of protection needs to be considered safety in the context of sustainability. And this is not what we are necessarily doing. So this is an important message coming from the conference. Just to give you some idea on that, sorry, let me go back. This is the safety glossary. One of the things that I really feel some difficulties when I'm in meetings is the way people refer to things with different meaning. And that's a complication, because what you call decommissioning may refer to some audience as something, and to other audience can refer as something completely different. Remediation is pretty much the same. If you go to Japan, I think I will explode my time, Karen, because there are so many things to talk about. Remediation, for example, in Japanese is a word that does not exist. And they use the word decontamination instead of remediation. And that has a consequences in the outcome of the whole thing, because decontamination means rip out the contamination. And that what caused was essentially generation of huge amount of waste that now need to be managed. And then, look, they come and say, well, this material, this soil here is contaminated, so it's dangerous. Let's remove that. And now they created a lot of material waste that has to be transferred to interim storage facility and then to a disposal site after 30 years. But then realize that, oh, this is not really sustainable. But let us put this material back into use under certain conditions. Now you need to convince the stakeholders that what was dangerous in one moment is not dangerous anymore. So, but the fact is that this word does not exist in the vocabulary remediation. Also, if you go to Russian, the words that are used for remediation is liquidation or recultivation. I don't know what does it mean, liquidation, but the lack of common understanding of some concepts is really very important. So this is why this glossary is very important. But sustainability is referred to in the context of nuclear security and not in the kind of things that we are talking about, right? So this is something that has to be reconsidered. The other point is the safety guide for management of residues containing norm and uranium production. The safety guide is mute, believe me or not. It was is very recent. It was produced 2 years ago or something like this. It is completely mute about sustainability and even less circularity. So the point is that to produce a document like this, one takes between 5 and 10 years to be adopted into national regulations. Although they are not binding documents, they are not binding, it takes even more, 10 years more. So the process of production of the report of the safety standard and implementation in national regulations can take very long. And when it's done, it's already too late, right? And this one is a safety standard. By the way, who of you knows about these reports? Have you ever seen one of them? Well, you see, oh, that's good. We need to do better because the majority doesn't know, but these are documents that can inspire member states to put together their own systems in place. It was seen in the conference, great acceptance of circular economy principles. By the way, the meeting we had yesterday in the other room was excellent. Very good discussions, participation of young professionals very actively. I really enjoyed the outcomes of the discussions. And we talked a lot about circular economy. The mindset that prevails is still focused on disposal. This is what we are thinking about in terms of the linear economy. Take, make, dispose. This is what we have now. But the discussions we had yesterday, and we are ongoing discussions within the agency, is that eventually circularity can be put in place to make better use, more sustainable use of our resources. Recognition that the currently regulatory system might not be in alignment with circular economy because the whole regulatory system that we have was developed under the framework of a linear economy. And that has to be reconsidered if we are to adopt circularity. And clearance, and this was my talk in the conference, clearance is a key aspect in this regard, because clearance allows you to take materials from what call a practice of an activity and make that material available for use. And this is, Mr. Phil Egidi, the key point in all the discussions, what kind of clearance levels we're going to have and allow for the safe use of materials in the context of the circular economy. This is critical. There was another document that has been recently, published this week about clearance, but my take is that it does not address this issue properly because the mindset is still a mindset of a linear economy. And when I talk about linear economy, is to move from this particular way of doing things, raw materials, production, use, non-recyclable waste, and move towards this system where we keep materials in the loop. So the discussion yesterday was said, okay, zero waste is not something that we gonna see so soon, but that's not the issue that we're gonna be 100% circular. But is the issue is to going to have the vision of to take the best use of materials in that particular loop. That's what the message that we are talking about. Also, in terms of risk, I understand that in US, decisions about remediation are very much risk-informed decision. But there has been a kind of a shift, especially under the context of the International Commission of Radiation Protection, to speak more about tolerable and not tolerable risk. So this is also in the mix. And important thing is the optimization of the process. And we will discuss this in the presentation this afternoon. A very important concept when remediation is optimization of the remediation process. I will skip this one. And the way forward, the conference was consider safety in the context of sustainability. Remember, radiological risks are not the only hazards. Consider how to implement sustainability assessments. Safety community is not enough. Work with other experts. Use sustainability as a common ambition to strengthen relationships. Deliver education and capacity building on sustainability. Language, develop clear definitions of key terms. I come back to this as an important point. Reconsider existing safety principles and concepts that will require a lot of courage to move in that direction. Promote existing instruments and tools that ensure safety and enable sustainability. Member states to ask IAEA to develop a vision and make explicit commitment to sustainability. develop a vision position statement with the International Commission of Radiation Protection, explore solutions that have potential to be more sustainable, communicate all the nuclear sector that takes sustainability and SDG as the starting point, develop and share case studies to be able to share practical examples and not to keep ourselves in a very thin air, just of a high level considerations. Challenge everyone to leave the comfort zone and disseminate conference outcomes, which is essentially what I'm doing right now. Okay, so shifting gears and moving to the core of the presentation. 5 minutes? Oh gosh. Really? So important is that in our understanding, remediation is anything that reduces the radiation exposure. Simply like this, bluntly. Remediate is reduce exposure. It does not entail anything that has to do with removal of all the material. Coming back to background. This is a very difficult concept to get people to understand. The activities that remediation is amenable to, I think that you know very well. I just spoke about this, and remediation in terms of end state, that was the objective of my presentation that I screwed up, was essentially to the end state is in relation to remediation as the final status for a site at the end of activities. So this is the operational framework that we work. We have incorporated the principle of sustainability in that particular document, and we put forward selection and achievement of remediation and state that should consider sustainability and long-term protection. This is a starting point to have policies established, well, indicating essentially the embracing the principles that are relevant for remediation, such as justification, optimization, appropriate protection of future generations. This is where sustainability comes into play, efficiency in the use of resources, open and transparent interactions with stakeholders. So it is very important to have policy well-defined to be used in remediation. And we put together this report, and Mike Truex was the chair of this report, and also had the contribution from NDA in UK representatives. So this report is about the definition of remediation and state, and two levels are defined at the strategic level and the tactical level. And this is the scheme that we propose in the document to be adopted, and I was just want to focus on end state determination process and talk about the key enablers. So in the document, we recognize that national policy is a very important enabler for defining end state. Legal and regulatory framework should exist. National waste management strategy should also be in place, and confidence of interested parties in the process and decisions end state. So we can see that from the beginning to the end, the confidence will increase if you have proper mechanisms to implement that particular conversation. Important point that is introduced by the report is the interim end state, when it's not possible to define the final end state, the final end of the story. So you can agree on an interim end state that can be agreed upon in the process as something that is tangible, but will not be the end of story. So the document make reference to this. It's also a follow-up, a document that has been produced by another sister organization of the IAEA, by the NEA, OECD. NEA is the Nuclear Energy Agency, which is essentially composed not by 176 member states, but 30-something countries. And they talk about adaptive remediation that Tom just mentioned, zoning, operable or management units, use of long-term stewardship, waste management constraints, stakeholder opinions, decommissioning constraints, environmental constraints, and funding constraints. By the way, we at the agency, as per the determination of the member states, we have a differentiation between decommissioning and remediation. I understand that many of the countries work in a very well-established integration of both, but we understand, and I will explain this in the afternoon, that decommissioning is a process that is related to some specific situation, and remediation is something that is apart. I think it's a mistake, but this is the way we are organized. So this is the proposal of this document. And for the sake of decommissioning, there is another, and this is exactly the problem that we see. So we have a report on determination of end state for remediation, and there is another report coming out for the completion of decommissioning. This is what it is, conduct. And if you see the structure of the document, they are pretty much similar. And one would ask, why don't you work only with one document? Because essentially we see decommissioning and remediation as not part of the same thing. When we think about remediation in the context of decommissioning, what we have is to call cleanup instead of remediation. Why? Because the framework for remediation is different for decommissioning. I cannot explain this right now. If you are with us this afternoon, you will understand better what I'm trying to convey here. And I would go a little bit into the decommissioning from a presentation from a very nice guy, Frank Wigley from NDA, but I will skip this one and we'll come to my conclusions, Karen. Land remediation is framed by what is safe, and environmental safety case must be made. So this is very clear. Optimization and the consideration of controls is more than radiological protection. It has to involve environmental costs, work and public safety from operations, social values, reuse of material and assets in the context of circular economy, intergenerational equity. Important is to have good record keeping, and proactive change controls should be established early and proportionately, and manage uncertainty. That will always be a very important task to be considered. So I'm afraid that I run a little bit, but I wanted to talk about too many things, but I guess that the message was somehow shared, and I'm really here happy to address any questions that you might have. Thank you very much for your attention.
Good horse. Did get a question in the chat, and it might have really been directed to you, Tom, but both of you can answer. And I thought it's worth always being sure we're watching our folks in the chat. So the question was, when discussing complex sites, are former nuclear test sites considered, and are there any specific concerns associated with those sites?
They certainly are part of complex sites. I mean, especially if they have the characteristics of that. But I'm not personally involved in much of the nuclear test site remediation and characterization activities. I know some of my colleagues are, but I'm not, so I can't speak to any special elements of the testing. An example, for example, I'll give, which is we recently completed a study for DOE on the Inuiatok Atoll relative to issues that Congress asked about in terms of climate change and its potential impact on release from that nuclear test site and the Runit Dome that's covering up the waste there. And so, lots of issues around how do you maintain that safely and securely, and in a climate change scenario, what's likely to happen, or a major storm scenario in the Pacific, what's going to happen to that contained waste, and what are the risks to the Marshallese and that type of stuff. So there's a document that we've published recently that's out, I think just completed public review last week, I think. But anyway, I mean,
that's a good example.
That's an example.
There'll be unique issues. Horst, any comment?
We have a project with Kazakhstan on the Semipalatinsky test site, and this project has been going on for quite a while. And important is that we don't speak only about remediation, but revitalization of the site. And this is a very important connection between remediation and revitalization. Thinking about Japan again, one thing is to promote cleanup of the site, but the other thing is to bring the site back to economic use, because the overall infrastructure might be disrupted. So we need to see remediation as a part of revitalization of the site. And this project we have with Kazakhstan on Semipalatinski is very interesting because it has been going on for quite a while, and definitely it adds a lot of complexity because of the specificities that a test site might entail. So if you have interested, you can just go to this sort of Google IAEA Semipalatinski that you'll see information about it.
Great, thank you. Thank you for the question online. Of course, can you click one more slide? Perfect. So we're going to have a 5-6 minute transition to our case study today based on challenges in the UK. Thank you very much.